show you what we're going to be working on our module page. I posted module 9 last night so that we could work on it today. And we're going to be going over this discrete distributions with simulations. And before I move on, this worksheet, it's not as exciting as the previous worksheets that you've been looking at. It actually isn't a hyperdoc, and I wanted to know your feedback on the hyperdocs. Do you like the hyperdocs where you can type right in and drag things? Or are you cool with these? What do you think?
I like the hyperdocs.
You like the hyperdocs? Okay, thank you, Angie. Y'all can unmute yourself and let me know what you think. Hey, Timothy, let me see your whole face, man. Come on, show those pearly whites too. There we go. All right, are you on? He's probably on his a computer that's not easy to shift. I'm thinking. Okay. All right. So now that I'm thinking about it, I think I'm going to actually do a different problem on this worksheet for you guys so that we have 2 videos of me doing the dice problem here and then another video of doing the probability problem over here. That might be a good thing to do. So I just changed. I called another audible. Imagine that. So anyway, we're looking at discrete probability distributions. Probability distributions are still the same thing that we had before, except anybody remember the difference between, who can tell me the difference between discrete and continuous? Yeah, look it up. Go ahead, Timothy.
Discrete is whole numbers only, and continuous is like fractions and decimals.
Yeah, you're close, because sometimes discrete can be fractions, but for example, shoe sizes, 6, 6.5, 7, 7.5, right? Shoe sizes are discrete as well, even though they do have fractions. But the thing with discrete, I think that you're getting at, is that it has gaps. It has jumps from one data value to the other. So we can't show discrete with a continuous curve like we've been doing. So with discrete probability distributions, we're going to have a table, or we're going to have a graph that's just basically sticks. Sometimes you can even have an equation for a discrete probability distribution. But what you want to do is always graph all the possible outcomes and then satisfy and then find all the outcomes to find a probability that specify that event. It's easier to just use an example. So this is an example of Jason, who's been playing in a softball league. And on any given at bat, the probability of each outcome on the right is given here. So what is the probability that there will be at least one runner? Well, let's first get to know this table. So notice on this table, can everybody see it okay? Okay. So we've got our variable is how many runners are on base when Jason comes up to bat. And what's my minimum amount of runners on base? You guys got to unmute yourselves when I'm here.
0.
Everybody mute, because you're going to be shouting out. Come on. Shouldn't just be one person. What's my minimum number of runners?
0.
0, right? Because there could be nobody on base, right? What's my max?
3.
3. And why is 3 my max?
There's only 3 bases.
Yeah, there's only 3 bases. If there were 4, they'd already be home. So notice I've got 0, 1, 2, 3. I've got my probabilities over here. And if you add up all those probabilities, what do you think they add up to, Atir?
1.
They're going to add up to 1 because they're going to be everything that could possibly happen. So let's make sure we all know how to read this graph. Destiny Ochoa, what's the probability that there are 3 people on base?
0.5.
Say that more carefully.
Oh, 0.05.
0.05. So that's 5%. When she says 0.5, that's 50%. So just be very careful when you read that. So 0.05. What we got? Alexandria Martin, what's the probability that there's 1 person on base?
0.45.
0.45 or 45%. I'm going to throw this one out there. What is the mode? What is the mode of this data set? What is the mode? Who wants to try that one? Anybody want to raise their hand?
0.5.
What's that?
0.05.
0.05, not the mode. Good try though.
0.45.
Not the mode. Getting closer though. You're looking at the right row. So
one base.
0.545. Remember, guys, that's the probability, right? So it's telling you where the mode is, but the mode is what the data is. And what's our data?
One base.
Runners on base. So the mode, Alexandria was on it. She had the 0.45, but the mode is 1, right? Because that's what we're looking at. 1, and most of the time when Jason comes up to bat, there's 1 runner on base. Do you see what you did, Alexandria? Yeah, very good though. I mean, you're looking in the right place, just got to look at the right thing. So when we say probability of at least one thing that I want to make clear to you guys is even though, even with the hyperdocs, you guys should get used to writing probability the correct way as well. So I know this says at least 1, but I would want you to be able to do this, to know that that means probability that X is, what does at least 1 mean in relation to that 1? At least 1 means, can it be 1 if it's at least 1?
Yes.
Yes, so it can be equal to 1. And then would it be 0? Is 0 at least 1?
No.
No, because at least means 1 is the lowest, and I'll take everything up. So I'd want you to be able to write this as X is greater than or equal to 1. Okay. And when we look at this, that includes all of these values, right? 1, 2, or 3. And notice how the book did it is they added up those probabilities of 1, 2, and 3 to get the probability of at least 1. I personally like to use fewer numbers if I can. So what I did is I looked at the complement instead of doing, adding up 1, 2, 3. I looked and I saw, well, 0 has a probability of 30%, right? So I just did, well, it's going to be 1 minus the probability of 0 happening. And so that's going to be 1 minus 0.3, which ends up with the 0.7 as well. But the reason I do it this way is I know the more numbers I have, that means the more mistakes I'm going to make. So I like to use the complement. When there's a lot of things to add up, just use the complement and you have less mistakes to make. But either way is okay. Notice I end up with the same answer.
One other thing I like to point out is that when you always look at this table right here, what I want you to know is that when you add up the whole probability, this always has to equal to 1. If this is actually a true probability table, it always has to equal to 1. If it's not equal to 1, then it's not considered to be a probability table. Okay?
And when you create your thanks, Paul. When you create your probability distributions, you always check this and make sure that the sums add up to 1. And if you don't, you probably forgot an event. You forgot to list something that could happen. And if you have too much, you probably double counted something. So let's go to the worksheet. I'm going to clear these annotations. Because this worksheet, so I'm going to do this problem number 2. I'm a little nervous, can you tell? Because I wasn't prepared to do this. I just, see, instructors, I don't just call audibles on you guys, I call them on me too. This is, both of these are carnival games. I like teaching expected value with carnival games just because in class I can usually have them play a carnival game. But we love this Zoom environment. So can I please have somebody who wants to volunteer to read this problem for me?
In order to raise some money, a school carnival has the following game. The player throws a dart randomly at the dartboard shown below. The payoffs are as follows. If the player hits region, what the heck?
A, yeah.
Yeah, sorry. They win $12. Region B, $6. Region C, $3. And Region D, $1. It costs $5 to play the game. Note, assume every time a dart is thrown, it hits the dartboard in one of the regions. Okay.
So where do you want to hit in this game? Where do you want to hit? Actually, I need to do what I usually do. So that's great. That was a bunch of words. And a lot of probability is a bunch of words. Who's going to read it the second time? Because Lord knows I need to read it a second time. So let's go with, who have I not heard from yet? Let's go with Michael Barrett. Michael Barrett, go ahead and read.
In order to raise some money, School Carnival has the following game. A player throws a dart randomly at the dartboard shown below. The payouts are as follows. If the player hits region A, they win $12. If they hit region B, $6. Region
You're going
C,
too fast. You're going too fast. Region C,
Sorry.
go ahead.
$3.
Uh-huh.
And region D, $1.
All
It
right.
costs $5 to play this game. Note, assume every time a dart is thrown, it hits the dartboard in one of the regions.
Nice. So what I do is I have a daughter who has a little trouble processing like all the information. So she has a really cool system where she circles all numbers and she underlines kind of the things associated with those numbers. And then she likes to box important words. So in the first one, A, what is the probability? That's what you're trying to find. She likes to box those. So I like to take my time. Our problems are going to get really intense. Part of statistics, I feel like statistics is like 4 classes in one. One of those classes is accounting, and having a system for how you're accounting for your information is going to be very key. So do not, sometimes college students are like, I'm in college, I can just know this. No, you still need these tools. You still need to mark down, circle things that are important. That's what academics do. We make notes of what's important in these problems. So this is a geometry question, and I don't want to spend too much time on the geometry because I don't think I'm going to give you something this difficult on an exam. But anyway, who remembers how to find? These are all squares, and we're assuming that the dartboard will hit the board. If it doesn't hit the board, we'll let them throw again. Okay, they're so bad, we'll let them throw again. So the first thing, if I have this outside square, this outside square of the dartboard is 8 feet. So if I wanted the whole square, how much is the area of that whole square? You guys remember?
64.
Yeah, so the area of the big square is going to be, and I should probably let Paul, you have a nice thing to write on, right?
Got it. So area.
I might let you, you can write on it, right?
Yeah. So let me actually.
So the area
I'm doing.
Yeah, go
Give
for
me
it.
just 1 second. I'm gonna actually, before I do that, let me actually upload this to here. Send copy to.
Ooh, here's the
All
big
right,
square. Ooh, I
sorry.
can make that. I'm like just seeing what I can do here. So this is the 8 by 8, yeah? Go for it. And you can write on mine, right? Right, Paul?
Oh, I
you can
can
share.
write
No,
on
that's
yours,
fine. Go for it.
actually.
No, go for it. You're good.
So this is this one. So you are right here?
Mm-hmm.
Here?
Yeah.
Okay, so area A is 8 by 8, which gives me 64. Is this in feet?
That's actually, I would just write area of the big square because A is the middle.
Oh,
A is the middle.
okay, area of, okay. So area of the big square.
I just write big.
And I say that. Okay, underscore.
Okay.
Okay.
So that's going to be, and that has square feet attached to it. And then we've got the next one. So if you look, the next square in is the area of A, B, and C. So the area of A, B, and C. Yeah, that one. So I just call that area
so
A, B,
I'll
C.
color code it.
Yeah. Oh, wow. You're fancy.
Okay, so that's going to be that. So this is going to be then 6 feet. So 6 feet by 6 feet. So we'll get, that should have been square. And we get square feet.
Fantastic.
Okay. Let's keep going.
Yeah, go for it. And then the next one, as we work our way in, the area of A and B, who can get that area for us? Talk them through it. Atir, you want to talk him through that? Called on Atir twice. He might need a spin. So what's the length of the side of that square, Atir?
At here?
There you go.
For B is 4 feet.
Yeah, for A.
4
B.
feet. Very
Yeah.
good. 4 feet by 4 feet. So therefore, what's the area?
16.
16 square feet.
Fantastic. And
Good.
then inside, finally, the area of A.
Bullseye.
Yeah. I like this color coordination.
Okay. How about that?
Okay.
So Danielle?
Go for it. You can fill that one in for us, Paul. Oh, Danielle. He called on Danielle. Go, Danielle. I got you, girl.
Muting, unmuting? No?
Oh, I think I'm unmuting her and she's muting herself back because we're both.
No, okay. So 2, 1, and then it's 2,
Which gives us
4, or 2.
No, you were right.
4.
4. Go with your gut.
4 square feet.
All right.
I know I put you on the spot. Sorry about
No,
that.
I like that. So now, if we want to know the probability, now realize that we've got the probabilities of the whole squares, but we just want the little strips that are on, the outside. Now A is going to be easy because what's the chance that you hit, now the probability, what's the chance that you hit region A? Region A has an area of 4 out of what's the big area of the whole dartboard? Yeah, the whole dartboard is 64. Does everybody see that?
64.
So over here
What
in
is
the
the-
probability of A, you only have an area of 4 out of an area of 64 to hit that dartboard. Okay. Don't simplify.
Oh, don't want to
Yeah, no worries. This is the only time, guys, you're going to hear a math teacher say, don't simplify, because it's going to be so much easier to have everything in the common
Fraction
denominator
form.
already.
Right.
Yeah. Yeah, and you can tell, Paul, I know, like, you're like, hey, coming from algebra or whatever, it's like, we always simplify, but
Right.
here we choose not to. Okay, so then how are we going to get region B? So we know that orange square is 16 square feet. And what do we have to do with region A to get that orange that he's shading there? What do we have to do? Now region A is different. We have to take it out. So what are we going to do with those areas? What do you think, Timothy?
Subtract A from B.
Exactly. We're going to take
Very
A.
good.
Dude, I love the way he even said it properly. Like, we're going to subtract A from B. That's fantastic. So B is 16 feet, and we're going to take away the 4. And so that's going to be 12 out of 64. Okay. I want everybody to try to get C now. So this region C, the green strip out here, you're going to take the big green square, and now you just have to suck out the orange square down here. Everybody do a calculation and show me your paper. What's the area of region C?
Or you can put it on the chat really quickly.
No, don't put it on the chat. They can copy. Well, I guess they can copy if they
that's
see
right.
their paper too. Yeah, put it on the chat. Go for it. I like to see their work though. I like to see it like written out.
So what do we get?
Nice. Timothy's on it. Ooh, we have our first fight. Alexandria
Oh.
does not agree with him. I like it though. Destiny. Okay, Destiny and Timothy. We got 2 votes for 20. We got 3 votes for 20. 1 vote for, or 2 votes for 24. So we want to make sure we see what we're looking at here. Cool. Okay, so what'd you do to get the 20, Timothy? You were my first 20.
I did 36
Uh-huh.
minus 16.
Okay. And then those of you who did 24, how'd you get the 24, Danielle, sorry. Oh, nice, Jen, nice. You're so savvy. Danielle, how'd you get your 24? I was just curious. Who else got 24? Adrian, can you tell me how you got the 24?
I subtracted 12 from 36.
You subtracted the 12. Where'd you get the 12?
From B, right after, yeah, right there.
Oh, so you went, so remember, yeah, so for the C, that's, okay, so now I know. So B is just the strip there, right? And we've got to suck out, so if you're going to do that, if you're going to do it that way, you take the area of C, the 36, you've got to suck out B, which is 12, but then you'll also have to suck out A. Do you see that?
You have to suck out.
Yeah, I see that. Okay.
Yeah. So you were close, but you still had, what you found was the area of this C and A together.
Okay.
But that's okay. This class isn't about areas, so it's all right. Now, I don't even want to work any harder. So how can I use what I know about, since I'm very confident that these answers are right, how can I use probability to help me get the result for D, without actually having to do D? What should these probabilities all add up to?
100.
If we're always going to hit the dartboard, these probabilities should all add up to what?
1.
1, absolutely. So I can just take 1, we know is 64 out of 64, right? So I can take 64, take out the 20, take out the 12, take out the 4, and I'd be left with something. What is that? 32 minus, is that 28? Might be actually easier to do it the other way. 64 minus 36, yeah, 28 out of 64 will be our probability for region D. Okay. All right, so this is where now, so let's all make sure we have those values. Written down, and then I'm gonna and then what we want to do is create a probability distribution in the form of a table. We can do a table, we can do a graph, whichever one you want. So we've now got the probabilities, but what we're really interested in is money, right? What we really want to do is see how much money we're going to win in this game. So Paul's going to create a table with our variable. Is it Y? Did I say Y or X? I think I was inconsistent. In part C, I say X, but I think I meant Y. Go back up to the top at the beginning.
Right here?
At the beginning, more. All the way. It says, no. Oh, I didn't name the random variable. Oh, my bad. Well, let's name the random variable. We'll name it X since I use X later on.
Okay, so you want me to just create a table here?
Yeah. Oh, actually, let's move to B. I forgot I had modified this from what I'm used to, because now I do. So everybody, when we're looking at this, what is, going back to this game, what is the observational unit that's happening here in this game? And what's the variable that we're recording in just the game, but not talking about the money yet?
The board.
What are we observing?
Yeah, what are we observing?
Player
What is the player doing?
throwing the dart.
Yeah, we're observing a throw of the dart. So the observational unit here is a throw of the dart. And then what is it that we care about with that dart? What is it that we're marking down? We're marking down the size of the dart. What are we marking down about the dart? About the throw.
What are we varying?
What is it?
Where it hits on the board.
Yeah, where it hits on the board. So the variable is the place it hits on the board, where it hits on the board. Because where it hits on the board is going to tell us how much money we've won. That's really what we care about. Let's be honest. Okay. And now we're going to, this is where I define the variable. So we're going to let X be the amount won. That's okay. Let X be the amount won or lost by a player in this game. And so if we want to create a discrete probability distribution, I want each of you to write down how much money can you win? What are all the possibilities? You might have to go back up to the start of the worksheet to look at those possibilities.
Okay. Start of the worksheet here.
Yeah. So if we're in region A, we win $12. If we're in region B, we win $6. And if we're in region C, we win $3. So these are all my values of X, and D is $1. So 1, 3, 6, 12. That's what I could win. But notice that it costs
You could lose
$5. Right? So I'm actually not winning $12. I'm actually winning how much? If they give me back 12 and I paid them 5, how much did I win?
7.
7, exactly. So to find out the net profit, I'd have to take away what I paid. Okay. So Paul, I'm going to jump over to StatCrunch right now and show them the table.
Sure.
Okay. So I'll show
Let me
no worries.
Share. Stop.
Cool. So now I've got the money won in the game. And so what I'm going to do here, now you guys for your table, the money I can win $7, right? I like to go with how much the most I can win. And then what's the next prize? If I hit region B, I get how much money?
$1.
Yeah, because they're gonna give me back 6, but I gave them 5, so I win $1. If I hit region C,
$2.
$2. But what about that $2?
You lost $2.
Did I lose $2? So they gave me back $3, but I paid them 5, right? So that's going to be -2. So, and then the last one is I lose $4. Is that right?
Mm-hmm.
Does everybody see where these numbers are coming from? So what you're going to have on your table, like the $7, that's the 4 out of 64, right? You'll write that on your frequency table, 4 out of 64, because you're writing a probability distribution. And then the next one, you'll have, more values with a denominator of 64.
12 out of 64.
So, but the problem with StatCrunch is that StatCrunch does not like, it's still in its infancy, and it doesn't like decimals as probability, as frequencies. It only works with real numbers. What I'm going to do for my table on StatCrunch is just remove the denominators and pretend this is going to be frequency. This is going to be the frequency out of 64 trials. So I'm going to take care of my denominator just by saying I'm going to live in a perfect world where I'm throwing that dart 64 times. And if that happens, I'm going to hit region A 4 times. Does everybody understand what I'm doing here? Since my probability of region A is 4 out of 64, I'm going to be expected in a perfect world. If I threw that dart 64 times, I'm going to hit A 4 times exactly. How many times am I going to hit region B?
12.
12, exactly, Destiny, good. And C?
20.
Yeah, you know what I want to do? What can I do? I don't want to do this. I never did this before, but just so that we all know what we're looking at. This is A, B, C, D, okay? And then you said 20? And then location D?
28.
28?
Yeah.
Whoa, my stat crunch just went a little nuts on me. There you go. Okay, so now in this case, all of these numbers should add up to 64 versus when they're probabilities, they add up to 1, which is 64 out of 64. But now they're going to add up to 64 because it's out of 64 trials. Okay. So this is my table. So my probability distribution, I just want to make sure you guys understand, your probability distribution should have the denominators under there. This is just modified for StatCrunch. Okay. But what's really cool is if you go to the stat calculator like we were working on the other day, the stat calculator, if I go all the way down to custom here, you guys see that? And I put my custom calculator. So for discrete variables, you're going to have to use the custom calculator most of the time. So I'm interested in my money 1. And the weights are my frequency. This is how often I win 7. This is how often I win $1. This is how often I lose, and so on. So I'm going to put frequencies there. And it's pretty cool. You push compute and bada bing, bada boom. So this is one way, and this is actually, I'm now going to rewrite this worksheet because I figure, duh, Angie, notice they've already given me the mean and the standard deviation of the population here. That's fantastic. I don't even have to go through summary stats. Oh, Michael, Alex, make a note of that. For the earlier one, we could have got the mean and the standard deviation right here. Forget everything else.
What is the mean telling us, though?
What's that?
So, I'm asking the students, what is the mean telling us right here?
Yeah, what is it telling us? Great question. So first of all, just acquaint yourself first before you look. That's a great question Paul's asking. Make sure you acquaint yourself with what's going on here. Notice this -4, all the horizontal, that's our table. That's the left side of our table. This is the money 1, -4, -2. What's this value in here? How much money did I win here? Where I'm looking over here.
$1.
$1. Notice it's in between the 0 and 2. Doesn't call it out exactly. And here's where I win the $7. Okay. So we've got the frequency, the height of these. Notice this height here, -4. This height is going to be, if you take 28 out of 64 on your calculator, that will give you that height of that stick. So it's really interesting, the discrete distribution, it's just a bunch of sticks because all you can do is hit things right on the nose. But when you see it in this form, I find it's like a lot easier to see the shape. If you had to name the shape of this distribution, what would you say the shape is?
Skewed right.
Yeah, absolutely skewed right. Okay. And again, what's the mode on how much money we're going to lose? What's the mode?
-4.
Good, Atir. The mode is -4. So the skewed right is going to pull the mean to the right, and it pulled it quite a bit. Notice here the mean is -175. So now that you've looked at this, what does that 175 represent for us?
You lost $1.75 playing.
One little phrase you have to add. That was perfect with one little phrase on the end. We lose $1.75 while playing on average. right? We don't lose it every time exactly, but sometimes we win, sometimes we lose. But it's like every time we step up to play this game, we can expect, basically, we're giving them $1.75. In Vegas, this would probably be too low. That's not good enough profit for them. They'd want that to be definitely more than 2. Anybody ever, I know you guys are all young, but if you ever play in Vegas and there's a game where you can win or push a lot, you'll notice there are some games in Vegas where they make you pay when you win. And that's because their expected value isn't what they want. So they make you pay on top of your winnings. They tax you. And it curses Vegas.
Yeah, this is your expected payout. So the player's expected payout. So therefore, you're actually losing every time you play on average $1.75, right? Which means that the house is actually winning $1.75. So that's why in Vegas, the house is always advantage, right? And they want to expect a payout of $2, right?
Yeah, exactly. And so notice the standard deviation is 2.9. So you could lose $1.75, but the standard deviation goes positive, right? If you add 2.9 to 1.75, so that will put you in the positive. Vegas won't let you do that. They won't let you do that. No. Every 1,000th person do that, but anyway, so this is your discrete. This is the table that you guys made, just in a graph form. And for me, it's easier to visualize the mean and the standard deviation. Notice if we use the range rule of thumb, we would have gotten a standard deviation. What's my range of my winnings? What's my range? Anybody remember what range is from last test? What's my maximum winnings?
$7.
Yeah, my maximum winning is $7. What's my minimum?
$2 or -4.
Yeah, I'm losing 4. So my range is going to be 7 minus -4. My range is actually 11. And so if I didn't have this information, the range rule of thumb says 11 divided by 4 would be my standard, or an approximation for standard deviation. What's 11/4, Michael? 2.75?
Yeah.
All right, I'll take that. So notice the range rule of thumb is close, but this is the more precise value here, the 2.9. But you can always estimate that standard deviation. Okay. I'm going back to the worksheet now. Oh, I love Paul's writing. No, keep it up there. You're good. You're good. Okay, so now we're all going to get to play the game, okay? I know you're really excited. And no, I'm not going to really give you money if you land on something you want to land on. So we've created our probability distribution, and now we're going to go in and we're going to simulate playing this game 500 times, okay? And then let's all make a histogram of our data values. So I'm going to go through, and it's going to be very similar to what we did the other day. We go to data. Where am I going to go next?
Simulate.
Yeah, if you want to simulate, go to simulate. And then all right, welcome back. So we go data, simulate, and then we've got custom, because it's none of these other distributions. It's the one we built in the table. So we go custom. Our values are going to be in the money one, and our weights are going to be my frequency of those 64 trials, okay? This is my population that I'm going to sample from. They said 500 times, right? We're playing. So my rows are still going to represent my sample size. And then I'm going to call this 500 throws of the dart. And there we go. Bam. First time out, I lost. I lost a lot. I don't like that. Yeah, I don't like this game anymore.
You're expected to lose.
I know, but come on. There's always that person in you that says, I'm different from average, right? I'm better. But how many of you got different things than me, right? I got -4 on the first one. Some of you might you lost $4 too, but some of you might have won on the first one because we all did something different, yeah? Everybody get their own? Let me know right now if you're stuck in the simulation. So everybody can get a histogram? No problem. So for the histogram, I was clear here. When you make your histogram, start your x-axis starting with -5 and just having a width of 1. It'll give you a better picture so that you can see each data value. So I'm going to go back in and do my graph of the histogram of my 500 throws. And my bins are going to start, I'm going to start at -5 so I can see a pretty picture and just have a width of 1. Everybody see that? And I know a lot of people like to put the value above the bar. I've been trying to do that just to be like everybody else. And then I push compute, and here's my scenario. Ugh, I don't like this scenario, but that's life in the big city, kid. So in my trial, 218 times, I lost $4. And if I hover over this, I can see I lost between $4 and $3. We know that that's the actual $4 mark, right? Over here, there were 51 times where I lost $2. There were only 34 times where I won $7. And again, for you, it's going to be slightly different. But how many of you got the skewed right shape? Did you all get the skewed? Raise your hand if you got the skewed right shape. Thank you. Thank you. All right. Cool, cool, cool. So for each of us, we got a little something different, but let's see what else we can do is go through the summary stats. And for our column, we can get our 500 throws of the dart and get our mean and our standard deviation for that. Again, we're going to use standard deviation here because this is a sample of 500 throws.
Can you go back really quick, please?
Yeah, of course. I'll cancel mine. So we're going to go to stat and summary stats.
Okay.
And I've got all my data in a column, so I'm going to go columns.
Okay, thank you.
Okay. And so I go mean, standard deviation, and I can just put compute. So again, notice I'm definitely short of the $1.75 that we were supposed to be losing. And my standard deviation actually went a little over, but it's pretty close to that 2.9. I think it was 2.90 that they had. And each of you, go ahead and tell me who's got theirs. Give me your mean and your standard deviation. Alexandria, do you have yours?
No, I do not. It wasn't working for my the simulate graph.
Awesome. So go in. I'm going to stop my share. You start yours. Let's go. You have a nice teal room too. My daughter would like, everybody's room is like teal and pretty in the background. My room is the best though. Just saying. Okay. So did you simulate the custom? Okay, so money. So in rows, Alexandria, put 500. You want 500 throws of the dart, and then one column there. And then you can label your column name down a little bit. You can name that just 500 throws if you want. Perfect. And now compute. Fantastic. So now you'll go into the graph, get your histogram. And then do the 500 throws. And our bins, start the bins, see where it says bins. Push -5 there. And go by ones for the width. Perfect. Now compute, or you can do the value above bar if you want.
Yeah.
And compute, and boom, there's her skewed right. Now hers is different. Wow, you hit 200 on the dot. She lost $4 200 times. And now you go to stat, Alexandria. So go on over to stat and summary stats, columns. and then the 500 throws again. And you want your mean and your standard deviation. So you'll click control or something to hold that down. There you go. Fantastic. Compute that. Boom. Her mean was negative 1.696 and her standard deviation is 2.88. So again, very close to the 2.9 for the standard deviation and off by what, 6 cents, maybe 5.4 cents from the true mean. Okay. Adrian, what'd you get for your mean and standard deviation?
For my mean, I got negative 2.834, and standard deviation, I got 4.214.
All right, let me see let's have you start sharing your screen. Let me see what you did, ma'am. Because that varies, but that surprised me how much that varied. Let me see. Oh, Adrian, I think that negative 7 there in your table should be a negative 4.
Oh, okay.
Okay, so notice, guys, so this is what we're going to be getting at. That was, Adrian, I really think, I'm going to give you a spin, man. Here, I'm giving him a spin. You stop your share so I can stop mine, so start mine. Boom, boom, boom. I'm going to override you because you get a spin for being wrong. Fantastic. Woo! 2 points. Yay, Adrian. Way to be wrong, man. But anyway, go back to your screen now. Share your screen again, Adrian. Because notice, we know there's going to be a little bit of variation. We're not all going to have the same answers. But see his numbers there? His numbers are way different. That $2.83 is too different from 175. And that's how I knew, hey, something's wrong with the data he collected. So he's got to go through and go through right in front of us. So we can't do this too many times. Data. And data. Simulate, yeah. Hi, my brain. I just caught a glimpse of the time, and I want to make sure Paul gets to where he needs to be when he needs to be there.
Throw one. Good.
Yep.
500.
Yeah. You're gonna need your weights too, Adrian.
Frequency, yeah. Weights.
There you go. Perfect.
Oh, this thing's like in the way. Okay, that's better. And then compute.
Mm-hmm. Now you've got your new data. That looks much. Oh, you know what?
We wanna compute, right?
You have to push 7. You have to push enter on your table where you put the negative 4. It hasn't digested it yet.
Okay.
So first push enter on that, and now resimulate. And I would, if I were you, delete those columns. You can just go to the arrow and delete those other columns. Because notice that's really weird. When you didn't push enter, it still was taking the negative 7s.
Wait, do I delete all these?
You can close those, but I'm saying delete the columns. The throws 1, you can delete that just by going to the arrow. Go up there, push that arrow, and delete column.
Oh, okay.
And delete the other one, just so it doesn't confuse you.
Okay.
Okay. I'm going to go back to my share screen because before the professors leave, the rest of you close your ears right now. I just wanted to show you guys, if I were to want to use, the summary stats on the population, if I didn't use, now that I got Stat Calculator, I'm going to use that, but I just want you guys to know StatCrunch a little more. StatCrunch, for some reason, does not like negative values. It won't give me the right answer. So what I would have to do is put in the money before the cost. So I'd go 12, 6, 3, and 1. And this is the money 1 without considering cost. And so if I wanted to get the summary stats for the population, I would go to grouped bin data here. And my bins are in the money 1 without the cost to play because those are all positive. And then my frequency is 64 trials. And then I'm going to get the mean, and I'm going to get the unadjusted standard deviation because this is a population. And then I'm going to compute. And my mean is 325. and my
Subtract
my
5.
unadjusted standard deviation is 2.9. So notice the 325, I would just have to subtract the $5 from to get my negative 175 in that
But it worked.
case.
But it worked out with the negative value. We got the same thing.
No, we got that in the stat calculator.
Oh, stat calculator.
Remember, we got that
okay.
in the stat calculator. Notice,
Uh-huh.
like, watch, if I did this with the negative, and maybe, watch, it's going to prove me wrong. But if I did this with the negative, I believe it screws up for some reason, because I don't know if it always does it or if it just does it sometimes. Whoa, I don't want all of those. I just the mean and the unadjusted and compute. Yeah, see that?
Oh, I see.
It always messes it up,
Uh-huh.
and I'm wondering and it even messes up the unadjusted standard deviation when you have negative values. So, so that's just something to be aware of.
Okay.
Now that I've seen the stat calculator does it, I'm going to always use that from here on out.
Yeah. So why
Yeah.
wouldn't we just do the stat calculator and give them the instruction and stat
Exactly. So I'm going to change my I'm going to change some things, and then yeah.
Okay. I think I'm
Okay,
gonna get out of here.
You go. Yeah. You have a great time.
All right.
Good to see you. Thank you.
All right. Bye. Thank you.
Bye. Okay. So
Bye, everyone.
Bye. Okay. So I'm going to, if you don't mind, I'm going to keep on moving just because I haven't done this problem yet, and I can post the video for everyone. Oh, I guess I should still share my screen. All right. So where are we at with this problem here? You guys, we're all supposed to calculate the mean and standard deviation for your 500 games and then interpret. So this is something that I want to make sure you guys are doing right, is interpreting these statistics. So what'd you get again? Oh, Manzo, wow. Manzo, where you been, my friend?
I've been here.
You been here?
Yeah.
Michael
I
Barrett,
joined-
has he been here the whole time?
You just so you're actually in the wrong section. This is the first section. You're in the black section, which is going to be the next.
Yeah, you go to Yee's room 2, man, room 2.
Okay.
Yeah.
I would have loved to have you here, but I'll see you later.
Okay.
Bye.
Take care.
Thanks, Michael. So who's mean? Timothy, what was your mean?
I actually didn't come up with one because I got lost as soon as I was putting in the values.
Oh, fantastic. Did you share your screen then?
Uh,
Are you just trying to get a spin by being wrong?
something like that, maybe.
Yeah, there you go.
All right. Where do I go for that? Oh, sure.
I think the bottom of the screen. You help him, Michael, because you're better than me at this stuff.
So if you are you in full screen right now?
Yeah.
All right. So if you drag your mouse down to the bottom, there should be a green share screen button. So you're gonna go ahead and select that, and then select share your desktop, and then you also want to click share audio. It's that little checkbox on the left, bottom left.
Am I good?
You're good.
All right.
And go into your, yeah, there you go.
Okay, so this is what I have right here.
Okay, fantastic. So you got 7, 1, -2. So now push return. I think this might be the same thing that happened to Adrian. Push return before, get out of that cell you're in. Push enter. Boom, now you'll be able to do it. Isn't that crazy? Just because you were in there, it wasn't reading it. So go ahead, go to stat, or data, sorry, data. Simulate. You tell me where to go. Be kind about it.
I'm going to go out on a limb and say normal.
No, guy, come on, classmates, help him out. Well, yeah, you're also quiet.
Custom.
Go to custom, yeah. So this is a discrete, we're just gonna go with custom. Talk him through it. Who's talking him through it? Oh man, Timothy, your classmates don't like you. What's up?
I think I should get an extra spin for that.
I think so. I'm feeling real sorry for you right now. Go ahead, help him out, guys. What's he gonna put for values?
Values
Click
for
on the values, yeah.
money one.
Mm-hmm.
And the second one, frequency. And then you want to do 500 rows in one column. And then for prefix, go down and name it 500th rows. And then compute.
Yeah, that was very succinct.
There we go.
There you go. You got a friend. And now go in and let's see your graph. Let's see your histogram. What shape do we expect to see? Everybody in your mind's eye, let's see what we expect. 500 throws. And let's start our bin. See where it says bins, Timothy?
Mhm.
We start our bin at -5 and go by ones for the width.
Mm.
Fantastic. Compute. I don't care about the value above the bar. I'm good. All right. Oh, that's what I had in my mind's eye. How about you? Anybody else see that before he even put it up there? Okay. So we've got, now go ahead and go to stat. Summary stats. And we'll just do the column of your throws. Fantastic. 500 throws there. And we want to get the mean and your standard deviation. So mean and then push control. Oh, go back to mean. Good. Now push control and go standard deviation. Oh, push mean. Are you on a Mac?
I don't even know what this is, honestly.
Okay. So you know that on your keyboard?
Yeah.
Push. Do you have a command key
Command.
or a control
You're
key?
using a laptop or a mouse?
Laptop.
Okay, hold down on mean and then click down and then hold down to standard deviation. What the heck? Like click on it and then like drag it down. There you go.
Oh, there's another trick. Okay. So we're going to get variance too, but we're okay getting more.
Okay.
Compute. So just make sure you mark your standard deviation. So you got a mean of -1.85, which is in that range of -1.75. And then your standard deviation is about 2.8. So close to the 2.9, not perfect, but that's life. So very good. So, so you're going to read those to me in a sec. I'm going to take over the screen now.
All right.
Okay. So, let's see, we're going to annotate. So we just got, remind me, my friend, we got your mean was negative. And I never know, Jen, do you know, when do you put the $sign? Do you put the negative and then the $sign, or do you put the $sign and then the negative? It always looks weird to me. Negative. What do you do, Jen?
That's a great question. And I'm thinking that I don't typically lose money. No, I'm just kidding.
I know, but I've always it always looks weird to me no matter how I do it. And my standard deviation, and for you guys, I am writing these out, but I mean, technically I should write that as lowercase s because it's from a sample and this mean is X bar. But whatever, we'll be fine. What was your standard deviation again?
2.8.
Okay, and that's also dollars, right? So dollars, $2.80. Okay, so what this would mean is that if I'm going to interpret, and I know a lot of you guys struggle when I write interpret, what this is telling me is that a player would expect to lose or win. Which one would it be? Which one would the player expect to lose or win? Would it be lose the $1.85 or win the $2.80?
Lose the $1.85.
Yeah, the mean is the center, so that's what we expect to happen. We expect to lose $1.85 on average. And then the standard deviation is telling us give or take $2.80. So remember with the standard deviation, we have the empirical rule, 2 standard deviations out is usually what usually happens. So we wouldn't be surprised if, I'm just going to round that $2.80 to $3. We wouldn't be surprised if we won, $2, if we have -1 and we add $3. We wouldn't be surprised if we won $2. We wouldn't be surprised if we lost $4. Okay. This is telling us what we would expect.
Professor Conley. For math, it's actually the negative supposed to go before the $sign. for like
Is it?
regular, and then for accounting they put a dollar sign and then parentheses the number.
Oh, did you just Google that?
No, it's because my sister's boyfriend's an accountant.
So it should be this negative
Negative, and then the dollar.
dollar.
Yeah.
That looks so weird to me. That's interesting though. But guess what? You just won a spin. Woohoo! Danielle. Boom. 2 points. 2 points for Danielle. That's fantastic. I'm so excited. And now I know something. And I'm going to remember you for the rest of my life, Danielle. Every time I write a negative number with a dollar sign, I will go, Danielle Rivera saved me on that one. I like that. And you think I won't, but that's true. I will remember you. I'll say it in class too. I'll be like, thank you, Danielle. Okay, so we're good there. So that's how much. And now we could also calculate the mean by hand, right? Because the mean is adding everything up and dividing by how many you see, right? So we could technically, I'm going to clear my annotations just because they're annoying. They're all drawings. So I can win $7. I would do that in a perfect world 4 times. I could win $1 in a perfect world. I would do that 12 times. I could lose $2 in a perfect world. I'd do that 20. So I just want to make sure you guys understand how to take a mean. Basically what you're envisioning is a bunch of data, and that 7 is you see how many 7s in the data set? How many 7s would you see in this data set?
1.
Nope. What is the frequency of my 7s? I'm going to see 4 of those, right? So in your mind's eye, look and see. You see 4 7s. Now how many 1s do you see?
12.
12. So you see 1, 1, 1, 1, 1, 1, 12 of them. And then you see how many negative 2s?
20.
20. So you see a lot more negative 2s than you see 1s, and then you see a lot more negative 4s. So to get that, using calculations by hand, I'm going to sum up all these things. So the mean of the whole population, the whole probability distribution, is I'm going to see 4 7s. So if I add 7 plus 7 plus 7 plus 7, right? Actually, let me change this because I don't want to. So instead of the mean, I'm going to write this as, I'm going to add up all my data, the sum of all my data. So I'll have 4 7s. I'm going to have 12 1s. I'm going to have, what was the next one? 20 negative 2s. And then I'm going to have 28 negative 4s. So that's going to give me my sum. Is everybody with me? And again, this is in a perfect world. This is our population. Michael better be with me because he knows I want the sum. 28 minus 40. Oh, gosh. That's on you, Michael. Everybody get your calculator out. Tell me what this sum is. And the reason we're multiplying again is when we do repeated addition, -4 plus -4 plus -4 plus -4. Why do that 28 times when we could instead do multiplication, 28 4s, -4s? Come on, Barrett. You miss being in my class, don't you, Michael? Michael was the best at practicing the, don't look at me. Don't look at me, Professor Conley. Look over here at Karen. He thought I didn't notice, but I noticed.
So it'd be negative 112 for the sum.
Negative 112. Anybody else get that? I hope so. When you add up all these values, notice they're going to be mostly negatives. And so the mean will be negative 112 out of how many values total? Again, back in StatCrunch. that annotate. Back in StatCrunch, how many values total did we have here? This is out of 64 trials, right? So I'm going to divide by 64 back on this page. Oh, and now it cut me out of my text. I have to create a new text box. Ugh. No, didn't work. So I'm going to divide that 112 by 64. And I'm going to get, I hope, okay, wait. Thinking of Danielle, negative 1.75. Is that right, Michael? Yay. So this means that everybody who steps up to this game is expected to lose $1.75. And there was, you might look it up. There was these two guys in I think it was Arizona. I'm thinking it's Arizona, might have been somewhere else, but this bar had put out, hey, we're playing this Keno-like game, and we're going to do it every night for the month of March. And these two guys in the bar, they're like, they computed the expected value just like this, and they found out that the expected value was positive. It was just like positive, like a nickel or I don't know, a dime. But so what they did is they came to the bar every night and they bought tons of sheets. They put their, they got their mortgage out on their house and they put all this money, and they ended up putting the bar out of business because they kept winning this game because the bar couldn't take it back because they had already advertised they'd do it every day. It's a fantastic story of where expected value can help you. Did you ever watch the show, what is it, Deal or No Deal? Any of you guys ever see that? When they first came out with that show, they would always offer, they had a certain formula on how much they'd offer based on expected value. So I could always predict. My friends would be all impressed with me because I'd be like, they're going to offer them this much, but then they changed it and made the formula more random. So it's not as exciting for me anymore. But anyway, if they're expecting to make $1.75 off each person, and 400 people are going to play this game, how much money would they expect to make? What do you think? What do you think we're going to do? Anybody want to take a guess?
700.
How'd you get that?
400 times $1.75.
Nice. So if you take 400, so ours is losing from our perspective, the players, we're losing $1.75. The school is going to make that $1.75 off of each person. So if you take the $1.75, multiply it by 400, you said what's Timothy? 700? 700 exactly?
Yeah.
All right. They made $700 if 400 people. So this is the way they can expect or they can anticipate what they expect to make in a game. Okay. And then the last idea that we've got to talk about here is to make this a fair game. So right now, people are losing. They're losing $1.75 when how much are they paying to play the game?
$5.
Yeah. So when the players, I'm not going to worry about typos. When players pay $5, they expect to lose $1.75. Right? So if the carnival just says, the carnival says, hey, we don't really want to make a profit. We just want people to have fun and break even. So a fair game when there's money involved means that your expected value is going to be 0. I don't want you to win or lose anything. You're just going to, show up, play, and leave with the same amount that you came with. That's a fair game when money is involved. So if right now they're paying $5 and they're losing $1.75, how can the carnival help those players to not lose that much? What can they do? What's that?
Lower the price of the game.
Yeah, they're going to lower the price of the game. And the way they're going to lower the price of the game, so for a fair game, the carnival should charge, originally it's $5, right? But they're going to take away that $1.75 off the cost so that the player doesn't lose any money. And so that's going to be $3.25. And then you can go through if you want and simulate this game playing with a cost of $3.25. You can set up a new probability distribution, and you'll see when you simulate and then calculate the mean, you'll be at the break-even point. You'll be at $0. It's kind of a cool little fact there. Anybody? I know it's a lot of information, but the main thing you want to be able to do with discrete distributions is make a table or make a graph of the discrete distribution, and then be able to simulate that to calculate the mean and standard deviation. Is Jen still here, or is she good? She must be good. How you guys feeling? Yeah. You're like, I'm so excited. We're going to have stats homework this weekend. Yeah. Right? Friday's a holiday, but not for us. We're doing stats. I mean, you don't have to actually be here, but I know you're going to be doing your stats, right? Oh man, they're wiped out. I'm glad we made these sessions now an hour and a half, over 2 hours. So you guys, I think you have 10 more minutes. Alex and Michael, you can start taking them through problem 1. And I'll give you host privileges. And I will say adieu. Thank you guys for being so attentive and involved. I appreciate it. I love it when you share your screens. And, stay with it. You guys got this. We only got, after this, we're halfway through. So dig down and you'll be all right. All right, I'm giving you host privileges.
Yeah, you can give me host. Alex has tutoring after this.
Nope, never had. What's that?
Alex has tutoring after this, so you can give me host.
Oh, I thought you were messing with me. Okay, you're host now. You guys, good luck. Michael's in charge.
I'm teacher now.
I'm leaving. See you.
Bye.
All right, guys. Oh, wait, hold on. All right. So let's go through number 1. So if you guys have your StatCrunch open right here, you guys can just create more columns. So whatever you have, it should be fine. So number 1, a carnival game consists of tossing 1 4-sided die and 1 6-sided die. The sum of their faces is recorded. The player wins if the sum is a multiple of 3 and loses otherwise. Can anyone tell what the observational unit is in here? What are we observing?
A die.
A die, right? Well, it's actually 2 die, right? It's a 4-sided die and a 6-sided die, right? So the observational unit is going to be a toss of a 4-sided die and a 6-sided die, right? What about the variable? What are we measuring, or what are we observing out of these dice?
How many times it lands on a side?
Yeah, so we want to know it's something about the sides, right? Now, what are we recording? We are recording the sum of the faces, right? So the variable is going to be the sum of the faces of the dice. Is the plural version of dice is die?
I think
Is that
so.
a thing? Is
I
it,
think
Yeah, die.
yeah, okay. Okay, cool. So die. Perfect. All right, C. Fill in the grid to the right and identify all possible outcomes of X, the sum of these two dice. So like, let's say, for example, we roll here a 1 and a 1. So then the sum is going to be a 2, right? So you want to fill this whole table out. So 2, if we do a 2 and a 1, that's 3, 4, 5, 6, 7, right? 2 and a 1, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. Okay. Now using the table to identify the number of ways to get each outcome, create a discrete probability distribution table or graph for this game. Okay, so we're letting X, and part C, they said X is the sum of these two dice. Okay, so the number of outcomes that we get, outcome is the sum that we're getting, right? So if we look at all of the blues that I have filled out in the table, I have 2s, 3s, 4, 5s, 6, 7, 8s, 9s, and 10s, right? Those are all my possibilities. I can't get a sum that is not that. So then we're gonna have X, which is the sum. So 2, 3, 4, 5, 6. Oh no, wait. So yeah. 6, 7, 8, 9, 10. Right? Let me actually split this into 2, so not all the values are super crowded. So it's gonna continue over here. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Now the next column, that's gonna be our probability. So it's gonna be P of X, the probability that X happens. Okay. So now, what are the total number of outcomes? So total number of outcomes, that always goes in the bottom, right? Now, if we look above, we have 4 rows and we have 6 columns. So then that's equal to 24 possibilities, right? So this is how many total possibilities. So we know that we're gonna get all of our probabilities, our P's out of 24. So it's gonna be something over 24. So I'm just gonna fill that out for everybody. Over 24. Over 24, 24, 24, 24, 24, 24, 24. All right. And now the number that's going to go up here is the total amount that have what you're looking for. So for example, the first one, how many give you a sum of 2? So if I look at my, my table, the only 2 that I see is this guy there. So it's only 1. So then this is going to be 1 out of 24 right there. Then I go with the next one, 3s. How many 3s do I see? Well, I see 3 and a 3. So I have 2 3s. So then my probability for the 3s is going to be 2 over 24. And go ahead and fill all those out. So like, what's the probability of getting the sum of being a 4? Adrian, what do you think?
Can you repeat that again?
What is the probability of getting, when we roll the 2 dice, of getting a 4? So right now we're doing this guy here.
3 out of 24.
3 out of 24, perfect. And we got 3 because we got 3 4s right there, right? What about probability of getting a 5? Alex?
4 out of 24.
Perfect. Thank you. What about 6? Timothy?
Four.
4. Perfect. Thank you. Let's say 7. Atir? How do you pronounce your name? Atir? What is it? I can't hear you.
It's a tier.
Atir?
Yeah, that's fine.
Atir. What did you get for probability of getting a 7?
4.
4. Perfect. 4 out of 24. What about 8? Danielle?
Hold on, can I finish it really quick?
Yeah. Let's say Destiny. What did you get for 9?
I got 2 out of 24.
Perfect. 2 out of 24. And 10, we only have one single 10, so that's going to be a 1 out of 24. Okay. And then 8, we want to just count how many 8s we have. We have 3 of them there, so then we have 3 out of 24. All right. So now that we have this, part E, I might not have enough time actually for all of this. Anybody have any questions on this? No? We're all good? All right. This is due tonight, right, Michael?
Yeah, it's due tonight. And then if you do have any follow-up questions, you guys can follow Alex to the open tutoring session that's going to start in 1 minute.
Yes, I'm about to go over there. I'll be there until 2.
And they're going to go over this worksheet?
Yeah. Any questions on this?
Oh, okay.
Bye, guys.
All right. See you, Alex.
Bye.
Bye, guys.